In this video, we will touch on polymer synthesis. From which materials or which monomers can we synthesize polymers? Polymers are formed by polymerization. It is a chemical reaction in which a macromolecule, or in other words, a polymer, is formed from smaller molecules. This polymer can have a molecular weight of several thousand grams per mole because many small molecules are interconnected and form a long chain. Depending on which monomers are used or what kind of reaction, we can distinguish between addition and condensation polymerization. We are also talking about addition and condensation polymers. To begin with, we will look at what the characteristics of addition polymerization are. Addition polymerization is a characteristic of unsaturated hydrocarbon compounds. These are alkenes and alkynes. In addition to the double and triple bonds, these alkenes and alkynes may have additional functional groups. Using the appropriate initiator, the latter breaks down into radicals, the radical reacts with a double bond, and the radical site is shifted to the end of the chain. In this way, the growth of this polymer continues until we get a long chain. Initiators usually disintegrate under the influence of UV light or temperature. Most plastics are synthesized by addition polymerization, from polyethylene, polyvinyl chloride, and polypropylene, to polystyrene. Polyethylene is listed here twice, once as HDPE and once as LDPE. These are high-density polypropylene and low-density polypropylene. The repeating unit shown in the figure below is identical in both cases. Still, the difference between the polymers is that in high-density polyethylene, the polymer is not so much branched. Therefore, the density of this material is higher, while low-density polyethylene is more branched and consequently has a lower density. In condensation polymerization, the cleavage of a smaller molecule occurs. Polyesters and polyamides are synthesized in this way. Among polyesters, polyethylene terephthalate is the most widely used. The synthesis of this polyester and the monomers from which we get this polymer are shown in the figure. These are ethylene glycol and terephthalic acid. If you look at the repeating unit of this polymer, you see that the number of atoms is less than the number of atoms in the monomers. This is because water is formed as a byproduct of this polymerization. Among polyamides, you are probably familiar with nylon. It is synthesized by the reaction between an acid and an amine. Again, a characteristic amide bond is obtained, and again the reaction produces water as a byproduct. Another example of synthesis may be the reaction between an acid chloride and an amine. The acid chloride is more reactive than acid and reacts when it comes in contact with another monomer. We mentioned various concepts, from plastics to polymers, polymeric materials, monomers, and repeating units. Later we will also get to know the concept of biopolymer. A monomer is a small molecule from which we synthesize polymers, but we should not confuse a monomer with a repeating unit. A repeating unit is that part of the polymer chain that repeats itself in the polymer chain. In chain polymerizations, the repeating unit is identical to the monomer. In addition polymerization, in which no compound is eliminated in the polymerizations, the repeating unit is identical to the monomer in terms of the number of atoms. In contrast, in condensation polymerization, the story is slightly different since here, the repeating unit is reduced by atoms, which are removed during polymerization. But how many repeating units should there actually be? There is no rule here, but the number must be high enough that with the additional units that would bind to this polymer, the properties of the polymer itself no longer change. In the case where we have only up to 10 monomer units bonded together, we are not talking about polymers but oligomers. What does the word polymer actually mean? It consists of these two Greek words. Polos means much or many, and meros means part. That is a lot of parts. The name itself suggests that a polymer is a large molecule made up of many repeating units that are bound together. We often deal with the term plastic or polymer material. However, polymers synthesized in the laboratory, nylon, or something else often do not have the suitable properties for specific applications or products. Because of this, we need to add additives, fillers, or additives to them. This gives those properties that are relevant to a particular application. As soon as we provide certain additives to these polymers, we talk about plastics or polymeric materials. And there can be a lot of these additives in the polymer. Due to this, some polymers have been justifiably problematized in the past, as the added substances can be released from the polymer after a particular time and enter the human body. If they are not inert or are even harmful to the body, this can be a big problem. Otherwise, these additives are not always added only for specific functions but also to reduce the cost of synthesis or the price of the material itself.